sequence given with an, that's the general term, converges or diverges. If it converges, determine its limit. In part A, we got sequence whose general term is 5n square plus 2n plus 20. So to check if the sequence converges or diverges, all we have to do is find the limit. If this limit exists, that means if we get a finite number, then the sequence converges. So limit of 5n squared plus 2n plus 20 all over 3n to the 5th power minus 3n squared minus 5. This is limit at infinity. And looking at n squared and n to the 5th, so the bottom grows much faster, okay, higher power. And we know from calculus 1, when we have higher power on the bottom, this limit is 0. Yes, this sequence converges and the limit is 0. So the sequence converges to 0. In part B, let's do the same thing. Limit of n going to infinity of an, let me write just an. Here is 3n to the 4th, n to the 4th. Oh, they are same power, n4, n4. Then the limit is just the ratio of leading coefficients, 3 over 8. So which is a finite number. That means the sequence converges. And the limit is 3 over 8, or converges to 3 over 8. Similarly, let's find the limit here. N cubed, n squared. The top grows faster, n cube. And we know when the top got the higher exponent, then this limit does not exist, or infinity does not exist. So the sequence diverges. Here, let's find the limit of 2 to the negative n. Let me make this negative exponent to positive. So we can do 1 over 2 raised to n. This negative put on the bottom, positive. And when n goes to infinity, 2 raised to very, very big is even bigger. And 1 over really big means 0. So the sequence converges to 0. Or the limit is 0. Here, let's find the limit of 3 to the n times 2 raised to 1 minus n. So we need to manipulate these factors first. Okay, 2 raised to 1 minus n is same as 2 raised to 1 times 2 raised to negative n. 2 raised to 1 is 2, and 2 raised to negative n put on the bottom, just 2 raised to positive n. So this is 3 to the n times 2 over 2 raised to n. And let's simplify further. This 2 number we cannot multiply with 3 or anything. 2 is here. 3 raised to n, 2 raised to n. We can write 3 over 2, 3 halves raised to n. In fact, this 2 has nothing to do with n. So we could have pulled all the way outside. Anyways, this is a geometric sequence because 3 halves to the power n. And 3 halves is bigger than 1. All that means when n is really big, this one goes to infinity because the top is bigger than bottom. Whenever we have a number which is bigger than 1, then this geometric sequence diverges. This limit is in fact d and e. You can think 3 raised to n over 2 raised to n. The top grows much faster than the bottom, so limit does not exist. That means the sequence diverges. Here, same thing. Just 4 raised to n. When n goes to infinity, this thing goes to infinity, 4 raised to very big. So this is in fact a geometric sequence. So same conclusion, the sequence diverges. Here when we have 2 raised to negative n, I put 1 over 2 raised to n. This is in fact same as 1/2 raised to n. So this is a geometric sequence with common ratio less than 1 or 1. So we have limit. Okay. Here is, let's find the limit of 2 raised to 2n over n plus 1. So we can take this limit to the exponent. So 2 raised to limit n approaches to infinity of 2n over n plus 1. That is 2 raised to, let's find the limit. Okay, this is limit at infinity, 2n n. If we just compare 2n and n, because these are the leading terms, we can think, oh, n same power, so 2 over 1. The limit is 2. Okay, you can just find the limit. Limit is 2. That is 2 squared, which is 4. So this sequence converges and the limit is 4. The sequence converges to 4. Here same thing, limit n going to infinity of 3 raised to n over n squared plus 1. Take the limit there, so 3 raised to limit n going to infinity of n over n squared plus 1. 3 raised to, now find the limit at infinity. So when n goes to infinity, this is n squared. Just look at the leading coefficient. The bottom got higher power. That means the limit is 0. Okay, the bottom heavy case. When n goes to infinity, the bottom got more power. It's like here, when we have fifth higher power, limit is 0. So this limit is 0 and 3 raised to 0 is 1. So this sequence converges and the limit is 1. The sequence converges to 1. So here is the last problem. 4 times 3, 12. 12 times 3, negative 36. Oh, these are increasing. If you want to write, okay, they go by multiples of 3. Alright, because 4 times 3. So multiples of 3. So basically 3 raised to n. If we take n equals 1, n equals 2, so let's say n minus 1. When n is 1, the first term, 3 raised to 0, which is 1, and we have negative 4. So we can just do, this is negative, positive, negative, positive. So negative 1 to the n. So I'm trying to write the common term, okay? So when we have negative, positive, that is negative 1 to the n. Okay, that gives us negative, positive, negative, positive. Then we have to get 4 as well. So first term is 4, so that's the 4. Then common ratio, when we 4 times 3, 12. So this is 3 raised to now n minus 1. That's the common term an. Okay, I'm not sure. Let's check. We have to get first term for n equals 1. For n equals 2, we have to get the second term, etc. When n equals 1, this is negative 1 raised to 1. That is just negative 1, 4, and 3 raised to 1 minus 1, 0. 3 raised to 0, which is 1. So that's negative 4. Yeah, that's good, at least for n equals 1. Let's try for n equals 2. Negative 1 square is positive 4 times 3 raised to 2 minus 1, 1. 4 times 3, 12. Okay, that's the second term. Let's check third term as well. N equals 3, negative 1 cubed, just negative 1, 4, times 3 minus 1 to 3 squared. So that is negative 9 times 4, 36. Okay, we are there. So this is good enough. So we have negative 1 to the n, 4, 3 raised to n minus 1. Okay. So this is a geometric sequence with common ratio 3. In fact, look at here, 4 times 12, 4 times 3, 12. These numbers are getting bigger and bigger. So obviously this diverges. Or the common ratio here is 3. So limit of an when n goes to infinity, these things are getting bigger and bigger. That you can just say dne, because you can treat in this way. That's kind of now alternative. The common ratio is 3. As long as common ratio is bigger than 1, this thing blows up. Okay, that's it. So the sequence diverges. You don't have to find the common term like this, because you can easily see where they are heading to. But in some cases, if the numbers were decreasing, then you had to find this to determine the correct limit. But in this case, it's just dne. The sequence diverges.